Good morning, one and all. I hope everyone is doing good. Now, guys, I welcome you all for the session 4 of this module 3, that is time response of feedback control system. Now, so far with this module 3, we have taken 3 sessions, session 1, session 2, and session 3, wherein with the session 1, as you remember, we understood the basic concepts of time response of feedback control systems via like transient response, then steady state response. Apart from understanding these two responses, later we concentrated with the 4 types of test input signals via step input, ramp input, parabolic input, and impulse function. Later we concentrated with the analysis of distinct orders of the system. As I remember, and as you people can remember, in the first session, we had covered the basic concepts along with the first order system analysis of feedback control system for unit step input. Is it okay? Later with the session 2, we concentrated with the basic concepts of second order system. Apart from understanding the basic concepts of second order system via open loop transfer function, closed loop transfer function, we understood what is xi, what is omega n, and also we understood the concepts of underdamped case, critically damped case, and overdamped case. Apart from knowing these 3 cases, we also understood the roots of the characteristic equation for these 3 cases. Is it okay? Apart from knowing these parameters, later we concentrated with the derivation part. That is the time domain expression for second order system for unit step input. That is C of t is equal to 1 minus e power minus xi omega nt divided by root of 1 minus xi square into sine of omega dt plus phi, where phi is equal to tan inverse of root of 1 minus xi square divided by xi. Is it okay? Those parameters we concentrated with session 2. Like even with the session 3, we understood the concepts of time domain specifications via what like delay time, rise time, peak time, maximum overshoot, settling time. Apart from knowing these parameters, theoretical concepts, where in session 3 we concentrated with the derivation associated with this rise time, peak time, maximum overshoot, and settling time. Is it okay? So far we covered most of the theory concepts, and one more theory concept is left out, that is steady state error. That steady state error I take up as soon as I complete the problems based on this theory concepts what I covered so far. Is it okay? First, in this session 4, we'll understand some of the basic problems associated with the first order system. Later, we'll proceed for like second order system. And from the point of examination, both are important. Like you can expect derivation or problems from the point of examination. Is it okay? Now, what is the learning objective? The learning objective is to apply the concepts of first order unit step response analysis to a given problem. Now, about the flow of content, we shall have the discussion of problems on first order system for unit step response. Now, first let me begin with problem 1, where we have one simple problem. Now, first let me understand the statement of the problem. Later, we'll think of what to do and how to evaluate the parameters. Is it okay? Now, first, if I make an attempt to understand the statement of the problem, what is the statement? It says, determine the output of a unity feedback control system. We need to find the output. Output is C of t. That you need to understand it clearly. Determine the output of a unity feedback. Unity feedback in the sense H of S is equal to 1 of a unity feedback control system whose open loop transfer function, that is OLTF, is given. OLTF is G of S. Closed loop transfer function is C of S by R of S. Is it okay? In the problem, open loop transfer function G of S is given 6 divided by S into S plus 5. When the input is a step of magnitude 3. It is not unit step response. It is step response with a magnitude 3. Is it okay? Now you can observe from the block diagram. This is the block diagram associated with the system. Is it okay? Now this is the open loop transfer function. feedback H of S is 1. This is unity feedback system, unity feedback negative system. Now what is R of S? Actually R of t is equal to amplitude 3 with a step of magnitude 3, that is 3 into u of t. Is it okay? If I apply Laplace for this, what is it results? R of S is equal to 3 into Laplace of this u of t is 1 by s. Thereby, what does this R of S? It takes 3 by s. Is it okay? Now this is the output C of S. But practically we are interested in determining the time response. That means we shall convert C of S to C of t by taking inverse Laplace. Thereby you need to be very good in basic concepts of Laplace. Is it okay? You need not to learn much more relations of the Laplace. You need to understand the basic concepts of Laplace, which we require for our application. That is more than sufficient. Is it okay? ನೋಡಿ ಇಲ್ಲಿ R of t ಇದೆ, R of S evaluate ಮಾಡಿದೀವಿ, H of S is 1. Thereby next I shall go for closed loop transfer function. What is closed loop transfer function? C of S by R of S is equal to G divided by 1 plus G into H. That is G of S divided by 1 plus G of S into H of S. I think no one has forgotten this generic expression. I think each one of you remember this. ಜ್ಞಾಪಕ ಇದೆಯಾ ಇಲ್ವಾ?
Yes, sir.
ಜ್ಞಾಪಕ ಇದೆ ಅಲ್ವಾ? ಹಲೋ, ಜ್ಞಾಪಕ ಇದೆಯಲ್ಲೇನ್ರಿ?
Yes, sir.
Okay, fine. G of S divided by 1 plus G of S into H of S. Now, from the problem, it is very clear G of S is available. Is it okay? H of S is also available. What is H of S? H of S is equal to 1. Why? Because this is unity feedback. Now, let me substitute this available terms as per the given. If I try to substitute this, now what is this? It becomes, this is G of S. 1 plus G of S into H of S. This 1 is H of S. This is H of S. Very simple mathematical relations. Even diploma students, you can understand this very clearly, no difficulty. Is it okay? Only basic mathematics. Now, after simplification, this I may cancel with this. Is it okay? LCM, this it goes to numerator, thereby 6 divided by S into S plus 5 plus 6. Is it okay? 6 into 1. Thereby, what does this? It takes the form S square plus 5S plus 6. Is it okay? Next step, actually this output what we have obtained is only C of, this is total C of S by R of S. Closed loop transfer function. Is it okay? Next I may factorize this. Factorization is very essential, guys. Like why we need to factorize this? In the sense, we need not to have C of S, we need to have C of t. Now what is C of t? Inverse Laplace of C of S. That means when we go for inverse Laplace, we need to go for partial fraction approach. When we need to have partial fraction approach, like product of the sums to be converted to sum, product of terms to be converted to sum, thereby we shall have products, later we shall convert that to sum. Is it okay? Next step, this is C of S by R of S. Next R of S I cross multiply. If I cross multiply this R of S, it comes over here. Now if I factorize this, you can observe this product is 6. 3 into 2 is 6. Basic factorization, what you have learned in your lower classes. Then 3 plus 2 is 5. Thereby, what are all the factors we have? Factors are, one factor is 3, one more factor is 2. Thereby, S plus 2 into S plus 3. Is it okay? Next step, C of S is equal to 6 divided by factors S plus 2 into S plus 3. This whole term into R of S. Is it okay? What is R of S? R of S as per this is 3 by S. Next step, if I substitute the value of R of S, this is 3 by S. This is not 3 by 5, this is 3 by S. Is it okay? Next, if I multiply this 18, 6 into 3 is 18. 18 divided by S into S plus 2 into S plus 3. ಈಗ ನಮಗೆ C of S ಬೇಕಿಲ್ಲ, what we require? C of t. Thereby, how do I convert C of S to C of t? By taking inverse Laplace transform. Now, in order to go for inverse Laplace transform, we need to have conversion from product of terms to sum of terms. thereby I shall go for partial fraction approach. ನೋಡಿ partial fraction approach apply ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚೆ ಒಂದು ಕಂಡೀಷನ್ ನೀವು satisfy ಮಾಡ್ಕೋಬೇಕು, that is the order of numerator should be less than the order of denominator. ಈಗ denominator order ಏನಿದೆ, third order, ಯಾಕೆಂದ್ರೆ ಎಸ್ ಎಸ್ ಎಸ್. Numerator order, it is zeroth order. Why? Because no s term. Thereby, the order of numerator is less than the order of denominator. If this condition satisfies, then only I can go for partial fraction approach, or else I can't proceed. This you need to memorize it clearly. Next, if I go for partial fraction approach, ನೋಡಿ ಇಲ್ಲಿ ಪ್ರಾಡಕ್ಟ್ ಏನಿದೆ ಅದನ್ನ ಸಮ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಸಮ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ this is the method what I need to follow. Constant divided by first term plus constant divided by second term plus constant divided by third term. ಇಲ್ಲಿ A0, A1, A2 ಅಂತ ತಗೊಂಡಿದ್ದೀನಿ. ನೀವು ಬೇಕಾದ್ರೆ A, B, C ಅಂತ ಆದ್ರೂ ತಗೋಬಹುದು, ಅಥವಾ B1, B2, B3, it is up to you. Is it okay? Thereby A0 by S plus A1 divided by S plus 2 plus A2 divided by S plus 3. Is it okay? Next step, how do I find A0? Now guys, I'll tell you one simple method to evaluate the constant values using partial fraction approach. It is very simple. Now A0 is equal to, now what is the overall relation? C of S. C of S into, ನೋಡಿ A0 ಗೆ associated term ಇರೋದು ಯಾವುದು? S. C of S into S at S is equal to 0. This is the simple relation what I need to use. Why I shall replace S is equal to 0? It is very simple. Now where does this S, it gets existed? Only at origin. ಅದೇ ರೀತಿ S plus 2 ತಗೊಂಡ್ರೆ where does this S plus 2 it gets existed? At S plus 2 is equal to 0 or S is equal to minus 2. ಹೇಳೋದು ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? Thereby this is the simple logic what you need to follow. The same method we follow for rest of the problems. I repeat, now how do I find this A0? In the sense, now the associated term, reference term is C of S into this S. Now how would the existence of this S at S is equal to 0? ಅದೇ ರೀತಿ S plus 2 ತಗೊಂಡ್ರೆ existence ಎಲ್ಲಿರುತ್ತೆ? S plus 2 is equal to 0 or S is equal to minus 2. ಅದೇ ರೀತಿ S plus 3 ತಗೊಂಡ್ರೆ S plus 3 is equal to 0 or S is equal to minus 3. ಸರಿ ಇದೆಯಾ? ಇಲ್ಲಿ S ಬದಲು S plus 2 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕಾಗ್ತದೆ A1 ಗೆ, A2 ಗೆ S ಬದಲು S plus 3 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕಾಗ್ತದೆ. ಎಕ್ಸಿಸ್ಟೆನ್ಸ್ ಬಂದು S is equal to minus 3. Is it okay? This you need to memorize it clearly. Next step, if I substitute the value of C of S, now what is C of S? 18. Now this, for one case I will show you in detail. The same thing is applicable for rest of the cases. Now you please try to refer to the top. Now this is, now A0 is equal to, is it fine? What is C of S? 18 divided by S into S plus 2 into S plus 3 into S at S is equal to 0. Where I may cancel this S and S. Is it okay? ನೋಡಿ ಇಲ್ಲಿ S cancel ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ S is equal to 0 substitute ಮಾಡ್ಬಿಟ್ರೆ it becomes indeterminate form. Is it okay? Like constant ಯಾವಾಗ್ಲೂ infinity ಅಥವಾ indeterminate form ಅಲ್ಲಿ ಇರೋ chances ಇರಲ್ಲ. Is it fine? Next, if I substitute S is equal to 0, this is 0, this is 0. Thereby 2 into 3 is 6. This is 6. Total evaluation after the resultant after evaluation is 6. 6 1s are 6 3s are. Is it okay? 18. Thereby what is A0? A0 is equal to 3. Next, how do I find A1? A1 is equal to, only one change I need to make. A1 is equal to C of S into associated term ಯಾವ್ದಿದೆ? S plus 2. Is it okay? At S plus 2 equal to 0 or S is equal to minus 2. ಸರಿ ಇದೆಯಾ? ಇಲ್ಲಿ S plus 2 term cancel ಆಗ್ಬಿಡುತ್ತೆ. ಕ್ಯಾನ್ಸಲ್ ಆದ್ರೆ ಉಳ್ಕೊಳ್ಳೋದು ಯಾವುದು? S and S plus 3. Is it okay? Now you can observe S and S plus 3, 18 as it is, at S is equal to minus 2. After simplification, it results with a value minus 9. Is it okay? This procedure you need to memorize it for further classes. ನೋಡಿ ನಿಮ್ಮ ಸಿಗ್ನಲ್ಸ್ ಅಂಡ್ ಸಿಸ್ಟಮ್ಸ್ ಅಲ್ಲೂ Z ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಅನ್ನೋದು ಒಂದು ಚಾಪ್ಟರ್ ಇದೆ, ಒಂದು ಮಾಡ್ಯೂಲ್ ಇದೆ. ಅಲ್ಲೂ ಇದೇ ಮೆಥಡ್ ನೀವು ಫಾಲೋ ಮಾಡಬೇಕಾಗ್ತದೆ. Is it okay? Like we shall follow the same method even for future semesters. Thereby, you need to adopt and you need to remember this method very clearly. ಈಗ ನೀವು ಪಾರ್ಷಲ್ ಫ್ರಾಕ್ಷನ್ಸ್ ನೀವು ಓದ್ಬೇಕಾದ್ರೆ ಫಸ್ಟ್ ಪಿ ಯು ಅಥವಾ ಸೆಕೆಂಡ್ ಪಿ ಯು ಅಲ್ಲಿ ಹೇಗ್ ಮಾಡ್ತಿದ್ರಿ, ಎಲ್ ಸಿ ಎಂ ತಗೊಂಡು ಲೇಟರ್ ಯು ಗೈಸ್ ಯು ಆರ್ ಕಂಪೇರಿಂಗ್ ದ ಕೊಯಿಫಿಷಿಯನ್ಸ್ ಆಫ್ ಎಸ್ ಸ್ಕ್ವೇರ್ ಎಸ್ ಅಂಡ್ ಕಾನ್ಸ್ಟೆಂಟ್, ರೈಟ್? ಯು ಕ್ಯಾನ್ ಆಲ್ಸೋ ಡೂ ದಟ್ ಮೆಥಡ್, ಬಟ್ ಇಟ್ ಟೇಕ್ಸ್ ಮೋರ್ ಟೈಮ್. In order to reduce the time, we shall use this method. Similarly, how do I go evaluate A2? Now, how about A2? Now, A2 is equal to 18 divided by S into S plus 3. Sorry, this is S into S plus 2 at S is equal to minus 3. After simplification, this it results with a value 6. Now, A0 is available, A1 is available, and A2 is also available. Substitute with this. Now, what is A0? 3 divided by S. This is A1 minus 9. Minus 9 divided by S plus 2 plus 6 divided by S plus 3. Nodi, illi ಏನ್ ಪ್ರಾಡಕ್ಟ್ ಇತ್ತು, this product has been converted to sum. ಈಗ I can evaluate the Laplace directly. This is the simple parameter what you need to follow. Is it okay? Next, I shall take inverse Laplace transform for this. If I try to take inverse Laplace for this, taking inverse Laplace, is it okay? C of S, the inverse is C of t. Now this 3 is constant. I'll keep as it is. What is the inverse of 1 by S? Which is U of t. Is it okay? This minus 9 constant. I'll keep as it is. What is the inverse of 1 divided by S plus 2? Which is e power minus 2t. Why? Because 1 divided by S plus A. The inverse Laplace is e power minus at. ಅಂದರೆ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಇತ್ತು ಅಂದ್ರೆ ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಬರುತ್ತೆ, ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ಟರ್ಮ್. ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಇದ್ರೆ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ, ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ಟರ್ಮ್. Is it okay? This you need to memorize it clearly. Simple like Laplace relations. This is minus 9 into e power minus 2t. ಅದೇ ರೀತಿ 6 constant. Now what is the inverse of S plus 3? ಇಲ್ಲಿ a value ಏನಿದೆ 3. Is it okay? Which is plus 6 into e power minus 3t. And this is the output for the given system with certain open loop transfer function. Is it okay? And analyze the overall output for the step input with magnitude of 3. Is it okay? And these are all the things what you need to follow. Simple parameters. Is it okay, guys? This you need to memorize it clearly. Next, I shall move on to the next problem, that is problem 2. First, let me understand the statement of the problem. For a single loop unity feedback system, unit step response, already output is given. C of t is equal to 1 minus 3 into e power minus 2t plus 2 into e power minus 3t. Evaluate the closed loop transfer function and also open loop transfer function and find the response to a unit ramp input. ನೋಡಿ, previous problem ಅಲ್ಲಿ open loop transfer function ಕೊಟ್ಟು input R of S ಕೊಟ್ಟು he has asked us to evaluate the output C of t. But this problem is quite reverse. He has given the value of C of t directly and he is asking us to evaluate open loop and closed loop transfer function. After finding the closed loop transfer function, later I need to find the C of t for ramp input. Is it okay? ಇದುವರೆಗೂ ಯೂನಿಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಅನಲೈಸ್ ಮಾಡ್ತಿದ್ವಿ, ಈಗ ಯೂನಿಟ್ ರ್ಯಾಂಪ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. Is it okay? Now what are all the parameters has been given? C of t. Output is given 1 minus 3 into e power minus 2t plus 2 into e power minus 3t. Is it okay? Like unit step response. Since unit step response R of t is equal to 1 or R of S is equal to 1 by S. ಈಗ ನಮ್ಗೆ ಏನ್ ಬೇಕಿರೋದು? ಕ್ಲೋಸ್ ಲೂಪ್ ಟ್ರಾನ್ಸ್ಫರ್ ಫಂಕ್ಷನ್. ಕ್ಲೋಸ್ ಲೂಪ್ ಟ್ರಾನ್ಸ್ಫರ್ ಫಂಕ್ಷನ್ ಬೇಕು ಅಂದ್ರೆ C of S by R of S. R of S is, how do I find R of S? From R of t by applying Laplace. Similarly, how do I find C of S from C of t? By applying Laplace. ನೋಡಿ, I shall apply Laplace for this. ALT. What are that ALT stands for? Apply Laplace transform. ಇದು ನೋಡಿ, after applying Laplace transform, R of S is 1 by S. ಅದೇ ರೀತಿ ಇದಕ್ಕೆ ನಾನು Laplace apply ಮಾಡಿದ್ರೆ Laplace of 1 is 1 by S. Minus 3 constant. Laplace of e power minus 2t, 1 divided by S plus 2. Plus 2 into, what is the Laplace of e power minus 3t? ನೋಡಿ, ಈ relation. E power minus at. What is the Laplace of this? 1 divided by s plus a. This is the relation what we shall use for this. Is it okay? Next is an LCM ತಗೋಬೇಕಾಗ್ತದೆ. This is 3 divided by s plus 2 plus 2 divided by s plus 3. Next, after taking LCM, what is LCM? S into s plus 2 into s plus 3. After simplification, this is the overall resultant. 6 divided by s into s plus 2 into s plus 3. This is only C of s. But actually I required closed loop transfer function CLTF. C of s by R of s. Now this is C of s. This is R of s. R of s is 1 by s. After simplification, this it to go once again, it goes to numerator. Yes, where I may cancel this s and s. Is it okay? 6 divided by s plus 2 into s plus 3. Nodi the s cancel ಆಗ್ತದೆ. ಅವಾಗ how about the left out parameter? This is the overall transfer function. 6 divided by s plus 2 into s plus 3. This is closed loop transfer function. But nano, apart from closed loop, I also need to find open loop transfer function. OLTF. OLTF is G of s. How do I find this? It is very simple. Now we know that C of s by R of s is equal to G of s divided by 1 plus G of s into H of s. ಇಲ್ಲಿ ಎಚ್ ಆಫ್ ಎಸ್ ಇಸ್ 1 ಯೂನಿಟಿ ಫೀಡ್ಬ್ಯಾಕ್. ಅವಾಗ ಏನಾಗ್ತದೆ, ಇದು ಎರಡನ್ನೂ ನಾನು ಈಕ್ವೇಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನೋಡಿ, ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಳ್ಳಿ. 6 divided by s plus 2 into s plus 3. This is g divided by 1 plus g. Our interest is to find the value of g. Open loop transfer function is g. ನೋಡಿ, ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಳ್ಳಿ. This is 6 into 6 plus 6g. Now this is s square plus 5s plus 6 into g. After simplification, this g of s, it results with a value 6 divided by s into s plus 5. Is it okay? Now closed loop transfer function is available and also open loop transfer function is available. Is it fine? Next I shall find response or output to unit ramp input. Now as you are aware, R of t for unit ramp input, R of t is equal to t into u of t. Or how about the Laplace? This is like 1 divided by s square. ನೋಡಿ, ಕ್ಲೋಸ್ ಲೂಪ್ ಟ್ರಾನ್ಸ್ಫರ್ ಫಂಕ್ಷನ್ ಎವ್ಯಾಲ್ಯೂಯೇಟ್ ಮಾಡಿದೀವಿ. 6 divided by s into s plus 3. This is overall transfer function. Next I shall multiply R of s to RHS. Next, what is this? It becomes C of s is equal to 6 divided by s into s plus 3 into R of s. Now this R of s is 1 by s square. Why? Because unit ramp. ಇಲ್ಲಿ ನೋಡಿ, ಯೂನಿಟ್ ಸ್ಟೆಪ್ ಕೊಡ್ಲಿ, ಯೂನಿಟ್ ರ್ಯಾಂಪ್ ಕೊಡ್ಲಿ, ಯೂನಿಟ್ ಪ್ಯಾರಾಬೋಲಾ ಕೊಡ್ಲಿ, ಇಸ್ ಇಟ್ ಓಕೆ ರೈಟ್, ಆರ್ ಇಂಪಲ್ಸ್ ಕೊಡ್ಲಿ, ಬಟ್ ನೀವು ಅದು ವ್ಯಾಲ್ಯೂ, ಲ್ಯಾಪ್ಲಾಸ್ ವ್ಯಾಲ್ಯೂ ನಿಮ್ಗೆ ಗೊತ್ತಿರಬೇಕು. ಇಸ್ ಇಟ್ ಓಕೆ? ಇಂಟು 1 by s square. Later partial fraction approach, product to be converted to sum. Is it okay? Thereby s square s plus 2 s plus 3, that is a divided by, ಇಲ್ಲಿ ನೋಡಿ s square ಇದ್ದಾಗ additionally we have one more constant term. This you need to understand it clearly. Next up, this is a naught by s square, this is a2 by s plus 2. ಇಲ್ಲ ಅಂದ್ರೆ ನಾವು ಹೀಗೆ ಮಾಡ್ಕೋಬಹುದು, ಇದನ್ನ ಫಸ್ಟ್ ಪ್ಲೇಸ್ ಮಾಡ್ಕೋಬಹುದು. ದಿಸ್ ಇಸ್ a naught divided by s square is one term plus a1 divided by s is the other term plus a2 divided by s plus 2 plus a3 divided by s plus 3. ನೋಡಿ, ಇಲ್ಲಿ ಸ್ಕ್ವೇರ್ ಟರ್ಮ್ ಬಂದಾಗ ಸ್ಕ್ವೇರ್ ಜೊತೆಗೆ ಫಸ್ಟ್ ಆರ್ಡರ್ ಟರ್ಮ್ ಇರುತ್ತೆ. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಕ್ಯೂಬ್ ಬಂತು ಅಂದ್ರೆ 3 ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ಬರುತ್ತೆ, ಎಸ್ ಕ್ಯೂಬ್, ಎಸ್ ಸ್ಕ್ವೇರ್, ಎಸ್. ಇಸ್ ಇಟ್ ಓಕೆ? ದಿಸ್ ಯು ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಟ್ ಕ್ಲಿಯರ್ಲಿ. ನೋಡಿ, ಎ ನಾಟ್ ನಾನು ಏನ್ ಮೆಥಡ್ ಹೇಳ್ಕೊಟ್ಟೆ ಅದೇ ಮೆಥಡ್. ಹೌ ಡು ಐ ಫೈಂಡ್ ಎ ನಾಟ್? ಸಿ ಆಫ್ ಎಸ್ ಇಂಟು ಎಸ್ ಅಟ್ ಎಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0. ದಿಸ್ ಇಸ್ ಫಾರ್ ಫಸ್ಟ್ ಟರ್ಮ್ ಎ ನಾಟ್, ಎಸ್ ಸ್ಕ್ವೇರ್. ಈಗ ನಾನು a1 ಗೆ ಎಸ್ ಟರ್ಮ್ ಎವ್ಯಾಲ್ಯೂಯೇಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಈ ಮೆಥಡ್ ಯೂಸ್ ಮಾಡಕ್ ಆಗಲ್ಲ, ಯಾಕೆಂದ್ರೆ ಇಲ್ಲಿ ಎಸ್ ಸ್ಕ್ವೇರ್ ಇರುತ್ತೆ. ಸರಿ ಇದೆಯಾ? ಸರಿ, ಇದು ಫಸ್ಟ್ ಎಸ್ ಸ್ಕ್ವೇರ್ ಗೆ ಐ ಶಲ್ ಮಲ್ಟಿಪ್ಲೈ ಬೈ ಎಸ್ ಸ್ಕ್ವೇರ್. ಇಲ್ಲಿ A1 ಗೆ S ಸ್ಕ್ವೇರ್ ಬದಲು ಏನಿದೆ S ಇದೆ. ಇಲ್ಲಿ S ಇರೋದ್ರಿಂದ ನೋಡಿ, ಯು ಪ್ಲೀಸ್ ಟ್ರೈ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಇದು S ಸ್ಕ್ವೇರ್, S ಪ್ಲಸ್ 2 ಮತ್ತೆ S ಪ್ಲಸ್ 3. ಇಲ್ಲಿ S ಇರೋದ್ರಿಂದ ಎಸ್ ಎಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತದೆ. ಸರಿ, ಇಲ್ಲಿ ಲೈಕ್ ಎಸ್ ಬರಲ್ಲ. ಎಸ್ ಸ್ಕ್ವೇರ್ ಇರೋದ್ರಿಂದ ಒನ್ ಎಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತದೆ. ಒನ್ ಮೋರ್ ಎಸ್ ಉಳ್ಕೊಂಡ್ಬಿಡುತ್ತೆ. ಈ ಒನ್ ಮೋರ್ ಎಸ್ ಉಳ್ಕೊಂಡಿರೋದ್ರಿಂದ ನಾನು ಎಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಇಟ್ ಬಿಕಮ್ಸ್ ಇನ್ಫಿನಿಟಿ. Is it okay? Constant can't be infinite. Thereby, this for finding A1, I need not apply the same method, but I need to go for derivative, first order derivative. ಇಲ್ಲಿ square term bandaga, you need to be careful. Now this is 6 divided by S into S plus 2 into S plus 3 at S is equal to 0, but I need to have the first order derivative of this. If I try to have first order derivative, U by V rule, what I learned in your basic derivation is like differentiations. Is it okay? V divided by like V into derivative of U minus U into derivative of V. If I try to use that relation and if I simplify, we used to have the value of A1 as minus 0.833. ನೋಡಿ, S term ಗೆ first order derivative, second term ಗೆ basic method. ಮತ್ತೆ ನೋಡಿ, ಇದು A3 ಮತ್ತೆ A2 ಮತ್ತೆ A3 no change. We shall use the same method. ನೋಡಿ, how do we get this A2? 6 divided by S square into S plus 3. ಯಾಕೆಂದ್ರೆ ಇದನ್ನ ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು. S plus 2 at S is equal to minus 2. After substitution, what shall we get? 1.5. Similarly, A3, 6 divided by S square into S plus 2 by avoiding this. If I try to avoid this, how would the substitution? S is equal to minus 3. ಸರಿ ಇದೆಯಾ? ನೋಡಿ, A0 is available, A1 is available, A2 is available, A3 is available. Then I shall go for inverse Laplace. If I go for inverse Laplace, you can observe this. Now for C of S, inverse is C of t, 1 by S square. 1 by S square is t. 1 by S is 1, wherein inverse of 1 by S square is t, or like Laplace of t is 1 by S square. Minus 0.833 is constant. Laplace of 1 by S is U of t. Idu beku andre barkobodu, or else it is understood. Is it okay? This 1.5 as it is. Inverse of 1 divided by S plus A is e power minus 80, e power minus 2t. Similarly, idu aste minus 0.667. Is it okay? Inverse of S plus A, that is S plus 3, is e power minus 3t. Is it okay? Nodi, ಇಲ್ಲಿ ನಾವು ಕೊಟ್ಟಿರೋ C of t ಗೆ ನಾವು ಕ್ಲೋಸ್ ಲೂಪ್ ಟ್ರಾನ್ಸ್ಫರ್ ಫಂಕ್ಷನ್ C of S by R of S ಎವಾಲ್ಯೂಯೇಟ್ ಮಾಡಿದೀವಿ, ಮತ್ತೆ ಓಪನ್ ಲೂಪ್ G of S ಎವಾಲ್ಯೂಯೇಟ್ ಮಾಡಿದೀವಿ. ಜೊತೆಗೆ we also evaluated the output for unit ramp input. Is it okay? This problem is concerned with first order system. This you need to understand it clearly. Second order ge like transfer function ಹೇಗೆ ಬರುತ್ತೆ? Like S square divided by S square plus omega n square divided by S square plus 2 xi omega ns plus omega n square. ಆ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. And these are all the problems concerned with the first order system. Is it okay? Now this is second problem. Next I shall move on to the next problem, that is problem 3. This problem is quite different when compared with problem 1 and problem 2. Now let me understand the statement of the problem. The overall closed loop transfer function of a mercury in glass thermometer can be taken as, this is the transfer function. C of S by R of S is equal to A divided by S plus A. Some transfer function has been given. And the thermometer requires 1 minute in indicating 95% of the response when subjected to a unit step excitation. ಅಂದ್ರೆ ಇಲ್ಲಿ ಔಟ್ಪುಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ. Is it okay? First order system output ಕೊಟ್ಟಿದ್ದಾರೆ. Output it reaches 95%. It reaches maximum value of 90% at 1 minute. ಅಂದ್ರೆ 60 seconds ಅಲ್ಲಿ. Requires 1 minute in indicating 95% of the response when subjected to a unit step excitation. Calculate the value of A. ಇಲ್ಲಿ C of t ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ, ಮತ್ತೆ ಟಿ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಟೈಮ್ ಅಲ್ಲಿ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇಲ್ಲಿ ನಾನು ಕಾನ್ಸ್ಟೆಂಟ್ ಎ ನ ಡಿಟರ್ಮೈನ್ ಮಾಡಬೇಕು. Is it okay? Now this is the response. You can observe this first order system. C of t. This is the maximum, but it reaches 0.95 at what time? 1 minute. 1 minute in the sense 60 seconds. This is t and this is C of t. Is it okay? Now C of t is given, t value is given. Now what we need to find? We need to find the value of constant A. Now this given closed loop transfer function is compared with the first order system, generic first order system. Now this is A divided by S plus A. First order system transfer function is 1 divided by Ts plus 1. After comparing these two, the value of T is equal to 1 by A. Then for unit step input, for generic response, for this, the output is 1 minus e power minus t small t divided by capital T. Is it okay? But we know the value of C of t at t is equal to 60 seconds. C of t is 0.95 at t is equal to 60. Nodi illi C of t ide, t value ide. Nanu ಏನು ಮಾಡಬೇಕು? I need to find the value of A. ಇಲ್ಲಿ ನೋಡಿ capital T is 1 by A. Thereby first I shall replace capital T with 1 by A. Is it okay? Or I shall retain this capital T as it is. Nodi C of t is 0.95. ಅದು ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ. 1 minus e power minus small t 60 divided by t. Taking natural log on both sides. After simplification ನೋಡಿ ಇದು 60 by t. ಇಲ್ಲಿ t value 20 seconds ಬರುತ್ತೆ. But what is A? A is equal to 1 by t, that is 1 by 20, which is 0.05. This is the constant value. This kind of problems you can also expect from the point of examination. Is it okay? Now finally, what is the learning outcome? Where we may able to remember and apply the concepts of first order unit step response analysis to a given problem. Is it okay? Similar kind of problems you can expect from the point of examination. These are all the problems concerned with the first order system. Then problems with the second order system I shall take up in the next session. Is it okay? And if you have any doubts regarding the problems what I covered,